Hello all, I'm Jaya Sreevalsan Nair, a faculty member at IIIT Bangalore. Today we will be talking about our work on segmentation of chart images to extract data. Bar charts, as we know, are one of the most widely used representation of data. They are so simplistic that we teach young children their early lessons in statistics and data handling through the use of bar charts. Here we are talking about digitizing these bar charts to extract information from them so that can feed into more advanced technologies such as screen readers for visually impaired. But these technologies are far from being done. That's mainly because the challenges involved in creating these technologies are threefold. Firstly, the bar chart images are sparse, which are different from the dense images we find of natural images. So the current image processing technology or techniques which are available and is the state of the art do not apply for these images. Secondly, these images are an output of software that help us to do plotting. Now such software also allow the users to format their images, right? So we can use different colors, textures, place legends where we want to, place text titles where we want to. Thirdly, the accuracy required of the data that's extracted from these images is on the higher side, much higher compared to the images that we see for natural images, photographs, etc. Right? So in our work, what we are trying to do is we take these bar chart images and use a computational model to represent these images. These computational models are derived from computer vision technique called tensor voting. This allows us to extract features and then extract the data from the images. This work has been supported by the Machine Intelligence and Robotics Center grant given by the Government of Karnataka to IIIT Bangalore. This work itself has been motivated by one of the themes developed at the eHealth Research Center, EHRC, at IIIT Bangalore, and the theme is on disabilities. This builds upon prior work on generating tactile diagrams for scientific diagrams from textbooks to promote STEM education for the visually impaired. This work has been implemented at MINRO, at EHRC, and the Graphics Visualization Computing Lab GVCL that I lead at IIIT Bangalore. Today, our students Komal Dadich and Siri Chandana Dagupatti are going to give us a demonstration of the tool that we have generated as a part of this work. This tool is called the BarChartDigitizer. Komal is going to walk us through the implementation of pre-processing where we annotate the images to prepare it to be used in a computational model. Siri Chandana will show us the front end of our workflow which uses the computational model in the back end and where we can see how the sample images are digitized, data is extracted, and we are able to reconstruct different charts from the chart that we have given. We can also extract the data in the form of CSV files. This work is far from being finished now. We intend to use machine learning algorithms and the state of the art in data science to improve our results. Enjoy our demonstration. Thank you for your attention. And we thank the Government of Karnataka for their kind support once again.
Hello and welcome. This video is demonstration of tool label image that can be downloaded from the Git repository mentioned in the description box. The tool is used for image annotation. We need to go to the corresponding directory and run the Python script to start the user interface and select the corresponding image that needs to be annotated. For example, here I have selected this bar chart image. Click on create rectangle box and select the area of interest to be annotated. Here we have selected these legends and we'll mark them as legend. The predefined labels for the chart images are canvas, legend, title, X and Y title, etc. So here the graphical objects contained in the current bounding box needs to be named as canvas. We'll label these X values as X labels. We'll label date as X title. Similarly, we'll label the Y components of the chart as well. The bounding box drawn for objects needs to be as precise as possible. If the image contains any chart title, we need to select a bounding box around that and label it as title. The same needs to be repeated if X and Y axis are being represented using a line. All the labels which are given to different components of the chart are listed in the right tab of the tool. We can click on any label and the corresponding bounding box gets highlighted in blue. We can readjust it if required. Also, we can edit the label and delete the bounding box if required. To save the information, we can click on save and the annotation information will be saved with the image name .xml in the default mode. If required, we can save it in a YOLO format, that is .txt. For our use case, we are using the XML format. Thank you for watching this tutorial of how we annotate the chart image for our bar chart analyzer.
Hello everyone, this video is a demonstration of BarChartDigitizer. We know today charts have become an essential element of visualization that can communicate information clearly and efficiently. Chart data is mostly communicated in an image format, which makes it harder for any non-visual reader to access the graph because today's screen readers can read the text clearly but the images on the screen are left unaddressed. So, we intend to retrieve the data back from a chart image in a tabular format, then making it easier for a non-visual person to access the data. We are focusing on developing a fully automated system designed to digitize a bar chart image. We now want to demonstrate our work of BarChartDigitizer. We can see on the left panel, we have few sample test images. We can choose an image of our choice and can work on setting the control panel widget. Once we check the toggle display box, we can see the extracted corner points of the chart image. We can uncheck it to go back to the original image. We extract these corner points using saliency values obtained from tensor field computation process of a pre-processed image. We pre-process the image using image segmentation techniques. We now can check the display reconstructed chart to see the reconstructed chart after data extraction process. This reconstructed chart helps us in understanding how accurately the data is extracted in a qualitative sense. We allowed the users to choose a specific color map of a reconstructed chart using a drop-down list for convenience. Now coming to the main purpose of BarChartDigitizer, we can download the extracted data in a CSV format and access the data. We now can see the extracted data file of a bar chart, which has 5 columns, 2 columns stating the data values and other 3 columns stating the titles of the bar. Coming to the extracted data values, we can see the shortest bar under very dissatisfied label has 4.6 respondents, whereas in data file it is 4.46. Coming to the tallest bar in under very satisfied label has 34.5 respondents, whereas in data file it is 34.6. This shows how accurately the data extraction process is done. We can check the data extraction file of other chart types, say this vertical grouped bar. Even this file has 3 columns for titles of the bar and rest columns for data values of each bar group along with bar width. Coming to the data extraction process, we can see under date D21, The weight of C52 value is approximately 1.5 in the image, whereas in data file it is 1.46, which is approximately equal to 1.5. We now want to demonstrate a special case of bar chart category called histograms. Whereas bins are represented as bars and the XY coordinates we retrieve will be bin centers and its frequency values. We check the extracted data frequency table of a histogram. This has same 3 title categories in the data frequency table along with other 3 categories called bin center, frequency and bin width. Say bin center with 61 has a frequency nearly 30 in the image, whereas in data file it is 27.37. Coming to the bin width, I guess the bin width is slightly greater than 2. In data file it is noted as 2.33. This bar chart analyzer is able to extract the data accurately for 7 categories of bar charts called simple bars, stacked bars and grouped bars in both horizontal and vertical orientations, along with a data frequency table for histogram. Thank you.